10 C's. We continue our adventures with three-dimensional solids. So today we're going to talk in this lesson about volume. Now, we're still dealing with solids, prisms, different kinds of prisms, whether it's cylinders that are circular prisms or square-based prisms, or they could be pyramids. If we have a rectangular pyramid. All right, we've done surface area with these. We're going to deal with spheres a little bit. So we worked with surface area of this, the amount of exposed surface, how much coloring, how much painting needs to be done if I were to cover these objects with paint. That's surface area. Well, today with volume, what we're looking at doing is two possibilities. Volume is filling an object. How much space does it have inside of it? Or it could be thought of as the space it takes up. So, my dad, let's be honest, used to call me blockhead. Lovingly, I like to think. But if you are thinking in terms of volume, and you think of me as being a blockhead, well, what does that mean? That means that I have a certain amount of space inside my head that can be filled. Now, let's be honest. The amount of space inside my head is pretty small because it's so full of brains. So there's not a lot of space left because the volume of my head is full of brains. But also, my dad calling me blockhead, my head takes up space in the environment. I've been told I've got a big fat head, so my head takes up a lot of space. Both of those could be thought of with volume. The only other thing with volume that's important to understand is we use cubed units. Now we used, even though it was 3 dimensions, objects, we did squared for surface area because surface area still covers flat 2-dimensional spaces. But when we talk volume, we are filling an object. The entire object is getting filled with stuff inside of it. So now we're talking cubed units. Centimeters cubed, meters cubed, feet cubed. Always make sure you're using appropriate units. So let's take a look at volume. Well, I want to show you where volume comes from because there's 2 formulas, and we're going to focus on first a prism, but we're also going to deal with pyramids in this lesson. They are very similar, but just different enough that if you miss the little difference, it's going to cause problems and get wrong answer. But where does volume come from? Well, how do we create a 3-dimensional object? Well, I like to think of a 3-dimensional object as being the base shape. So this particular rectangular prism, it's kind of like saying you have that base shape, and to then make it into a prism, 3 dimensions, you just keep adding more and more of those bases onto each other. And you just keep stacking base after base after base after base onto each other. And when you end up adding all those bases, when you stack them, well, all of a sudden, you end up with the 3-dimensional object. It's now got 3 dimensions to it. It takes up space all around. How did it take up space? It was the bottom shape. That bottom shape, which we can call the base. So the volume of a prism is based on the base of the shape. And then we took that base and we stacked it over and over onto itself. You just kept stacking the base. I just showed you. You stack and stack and stack, and it gets the 3rd dimension. So the volume of a prism is the base and then multiplied by the height of it. And what the big B represents is the area of the base. So in this first shape, what do we have here? Well, it's drawn to 3 dimensions, but what it is we have that rectangle on the bottom. That's a rectangle base. So we would get the area of the base. Rectangle is LW. But then we saw that those rectangles got stacked and stacked and stacked and stacked. And so we need to take the area of the base and multiply it by the height. So there's the formula for the volume, not just of a prism, but this is for a rectangular prism. This is what I call the general formula. Anytime you're dealing with a prism, think big BH. Then you can go to what I refer to as the specific formula, depending upon what kind of base it is. This was a rectangle base, so our big B became an LW, rectangle, times the height of the object. Well, let's take a look at the cylinder over here. Well, the cylinder is also a prism. It's a circular prism. So what you do is you think of it, you have this circle base, there it is once. But how do we then get the 3 dimensions? Well, we take that circular base and we stack them on top of each other. Base after base after base. And you start stacking these bases, and the single flat base, when you've stacked it, all of a sudden, the flat base is now a 3-dimensional object. So we can take that. Oh, that didn't quite work. Let me try that again. We can take that 3-dimensional, or that 2-dimensional round base, and when we stack it enough, this initial base, which is a circle, stacked enough times, we multiply that circle by the height. Area of the base times the height of the prism. So every prism starts as big BH. But for this cylinder, what kind of base do we have? We have a circle. So instead of just saying big B, we know that it's a circle base, so it's pi r squared, the circle base, times the height of the prism. The only other thing I want to point out about the prism is, or the cylinder, sorry, is when you have a cylinder and you want the height of it, the height doesn't always mean how tall it stands, because height could be the length of it. What height refers to is the distance from base to base. Because again, there would be a circle, and then another circle, and another circle, and another circle, and another circle, stacked and stacked and stacked. So we have the area of the base, which is our pi r squared, times the height, a whole bunch of those circles. Pi r squared h. General formula for a prism, specific formula because we know what kind of base we're talking about. Now I realize some of you are going to say, why even bother with the big BH? It's going to be the same every time. Only for the prism. We're going to change it up a bit with the pyramid. So let's take a look at these. These aren't in your booklet, but take a look at it. I want you to come up with the specific formula for each of these. Give it a try. Pause the video. Or just keep watching and we'll do them together. But give it a try and then come back. Now, what's important is every one of these is a prism. Here, prism, 2 triangles attached. It's a prism. Trapezoid, and a trapezoid in the back attached. It's a prism. Here we have actually a parallelogram, and a parallelogram in the back attached. It's a prism. So those are prisms. So we know right away, as soon as I see a prism, I should, with volume, okay, it's going to be big BH. It's a prism. It's going to be big BH. It's a prism. It's going to be big BH. But now I want specific formulas. What kind of base do we have? We have a triangle base because it's a triangle stacked a whole bunch of times to get the third dimension. So because the base is a triangle, our specific formula for this triangular prism, how do I get the area of that triangle base? 5/10 base times height. There's the triangle base times the height of the prism. There you go. Don't forget though, that first h would be the height of the triangle. The second h would be the height of the prism from base to base. Second shape. Well, what's the base that we have? We have a trapezoid. And that trapezoid is being stacked a whole bunch of times beside itself to give itself that third dimension. So because the base is a trapezoid, what's the formula for a trapezoid we reviewed a couple lessons ago? 5/10 B1 plus B2 times the height, and then times the height of the trapezoid. Again, a little bit of a goofy one because this first h is the height of the trapezoid. The second h is the actual height of the prism. So there's the general formula because it's a prism, and there's the specific formula because it's a trapezoid prism. The last one, parallelogram base. Well, if you recall, parallelogram is base times height, and then we multiply by height. Again, that h gets used a couple times. It can be confusing, but remember, the second h is the height of the prism. That first h is the height of the parallelogram. So keep them straight, what the h's are. They don't happen in all of them, but it's just area of base times height. So what we're looking at doing here, calculating the volume of a prism, it's very formula based. Substitute in, punch in your calculator. Please start with the general formula. You'll see in a couple minutes why. Convert to the specific formula like we just did. Substitute in the appropriate values and solve. So here we go. We have here a prism. So our volume is going to be big BH because it's a prism. What kind of base do we have? Well, we see that it's a rectangle on the bottom, and then a whole bunch of those rectangles could be stacked onto each other over and over and over. So because it's a rectangle base, LW times that height. So our rectangle is 4/2, and the height of the prism is 10. So the volume is 80 centimeters cubed. Simple, nice and compact, not nearly as involved as surface area, as long as you remember a prism is big BH, and you need to convert the big B to whatever formula you're dealing with. So a cylinder, prism shape, we know we're dealing with big BH. What kind of base do we have? Well, it's a circle, like we just showed, stacked on top of itself over and over and over and over. So my specific formula, my base is a circle, pi r squared times the height of the cylinder. Remember, pi, we use the pi button on the calculator, not 3.14. Diameter is given because it shows all the way across, so the radius would be half of that, 7.5. So it's pi times 7.5 squared times the height, which is 24. Pi times 7.5 squared times 24, what does that give us? That gives us 4,241, and tenths place is always a safe place to round to. 2/10 centimeters cubed, not squared like I almost wrote. Whew. That's it for a prism. Big BH. Big B has to change to whatever kind of base formula you have. Substitute in and solve. So let's move to pyramids. Now, I realize we have some pyramids and prisms on this, but we're going to see how prisms and pyramids are the same. Even got a little video to show you to demonstrate. So, what's important, let's just go up here. What would I do to get the volume of that prism or that prism? Well, we know it's big BH. Whatever kind of base we have times the height. Whatever kind of base we have times the height. We just talked about that. But there's a certain relationship. If you take a look at both of these combinations, when I move this pyramid up, what do I really hope you notice? Well, what do we see? We have the exact same base. This base and that base, when I put them all together, we see that they're exactly the same. That's going to be important. But we also see, hopefully, with this, that when I put them together, the heights are the same. This height of this pyramid is supposed to showing that it meets right in the middle of the top. So our height on that prism is the same as the height of that pyramid. So what I really have here actually with this pyramid is I have the exact same thing right now. I have the base, which is the same between the two, and a height, which is the same between the two. But we can see they don't take up the same volume. That's pretty obvious they don't take up the same amount of space, but we're going to see the relationship in a second. And that's the same thing with this cone and cylinder over here. If we take a look, you can see that the base of the cone and the cylinder is exactly the same. And the height of the cone and the cylinder is exactly the same. So again, even though this is a cone down here, I've technically got actually the exact same stuff. Same base, same height. But we see the volumes aren't the same. Let's watch this video. So, as you watch it, I'm going to talk about a couple key things on it. So, we don't really need the music. What you can see when this started is they have that same prism and pyramid. Let me just go back because I missed it at the start. They have the cube and the pyramid, and you see there that they have the exact same bases. They fit right on top of each other, exactly the same. So that's what the drawing showed. Bases are the same. Also, it showed, or will it? There you go. When you take a look at that, you can see that the heights are exactly the same. So that's exactly what I've shown on this diagram. Bases are the same and heights are the same. Here's where you need to see how they're related. Same base, same height, but obviously the volumes aren't the same. So the question is, we can take the pyramid and pour one pyramid into a prism. We can pour a second pyramid into a prism. We can pour a third pyramid into a prism. And what do we see? Well, we can see that that prism took 3 of the pyramids. All right, let's keep watching and see with the next shape what happens. So the next shape after we get to that. Let's skip that. We can go right to the cylinder, and here we go. Now they have cylinders. Note that the heights are exactly the same on the cylinders. The bases are exactly the same on the cylinder and the cone. So we're talking same height, same base. The question is, how many scoops of the cone will go into the cylinder? That pyramid into the prism. How many? Well, here we go. There's 1. They don't have as many cones this time. They can't keep them separate. But there's 2. Will the third one fit? When we take a look at it, you get 3 of the cones of those pyramids going into the prism. So what is that telling us? We had that situation, and 3 of these went into there. 3 of these went into there. So what does that say about these volumes? We have the same base and height, but the volume is 1/3 the size. When you have the same base and height, it's 1/3 the size. So there's your general formula for a pyramid. Almost the exact same as the prism, but you need to have it with a third, which is the same as dividing by 3. Because 3 scoops went in, this is 1/3 the size. 3 scoops went in, so this is 1/3 the volume. And there you go. That's what you're doing with a pyramid. So again, this isn't in the booklet, but let's come up with specific formulas. Has a point, an apex it's called. It's a pyramid. All 4 of these have apexes and points. They're all pyramids. So every one of these volumes is going to be 1/3 big BH. 1/3 big BH. 1/3 big BH. 1/3 big BH. New general formula compared to a prism. It's the biggest mistake I find students make. Prisms and pyramids, they're almost the same. But if you don't have the 1/3 on a pyramid, your answer will be totally wrong. Otherwise, it's the same process. We don't want a big B. This is the kind of base we have. Well, we see that we have a triangular base. So our specific formula would be 1/3. And because it's a triangle base, 5/10 base times height, and then times the height of the pyramid. The next one, we don't want big B to work with. This is just our thinking step. We see the ticks tell us it's a square base. So the volume would be 1/3 times S squared, because that's a squared base area calculation, times the height of the pyramid. Cone, we just looked at it, but what kind of base do we have? A circle. 1/3 pi r squared, because that's the kind of base that we have, times the height of the pyramid. And the last one, what kind of base do we have in this pyramid? It's a rectangle. So instead of big B, 1/3 LW times the height of the pyramid. And please note, when we talk heights now, well, we have to be careful, because before with surface area, we were talking about the slant heights. That was the slant height. Now we're talking vertical heights. H in these pyramids isn't the slant height of the side, it's the vertical height. You need to keep them straight. There's your slant height, but we need vertical height, straight up and down. Slant height, we need vertical height, straight up and down. So be aware of that. So let's calculate. How do we calculate volume of a pyramid? Can't stress enough. Oh, it's a pyramid right away. Pyramid means 1/3 big BH. Start with the general formula. What kind of base do we have? It's a circular base. So volume is 1/3. Our big B, because it's a circle base, becomes pi r squared, but we still need to multiply by H. So volume is 1/3 times pi. Now we need the radius of the circle. Well, radius is given. That's what we have there is 3, so 3 squared. And now we need the height. Well, we have 11 and we have 9. 11 is showing the slant height. That's a surface area value. We need the vertical height, straight up and down, so that'll be the 9. So the volume of that cone is 84.8 centimeters cubed for volume. Last one, maybe give it a try and turn on the video or just work along with us. So first thing, please take time. It's an apex, it's a pyramid. 1/3 big BH. Start with that. Don't forget, because that's where the error happens so much. What kind of a base do we have? Oh, the base is a rectangle. Don't get caught looking at the triangle sides. Base is what you have one of across from the apex. In this case, it's a rectangle. So we have 1/3 times the rectangle LW times the height of the pyramid. I'm just going to move up here so I have more room. So volume is 1/3 times the length and width of the base rectangle, 12 and 10. Length 12, width 10. And now we need the height of the pyramid. Here we have the slant height. That's a surface area value. Volume uses the straight up and down vertical height, which is 6.7. 1/3 times 12 times 10 times 6.7 gives us 268 centimeters cubed. Volume calculations. Not overly complicated. As long as you keep prism, big BH, separate from pyramid, 1/3 big BH. If you practice it, it won't be that bad, I don't think. All right, the last single shape is the sphere. Again, the sphere is special. Now, other special shapes with surface area was like the cone. The cone was unique, but this case, the cone fits in with volume, so it's not that bad. Here, though, we have a sphere. Volume of a sphere is that formula. Page 44 has a question that will walk you through the process. What's important is you know that that's the formula, and this can be used and will be given on an assessment. You don't have to memorize that. So what do we have? We have the diameter is 7, but we always want radius, so we need half of that, 3.5 inches. So the volume of a sphere is 4/3 times the pi, which is the pi button, times radius, 3.5 cubed. Now I haven't used the calculator yet, but let's just review with the calculator how we do the calculations. I got graph, let's clear, and there we go. Remember, we need to go 4/3 to start. And 4/3 on a calculator, you put in brackets. We talked about this previous. 4 divided by 3, there's our fraction, 4/3. We want to multiply that by pi, second function, and the little arrow exponent key gives us our pi value, not 3.14, but actual pi. And then we multiply that by 3.5 cubed. That little arrow key gives us the exponent 3. Hit the cursor to leave it. There's our 4/3 times pi times the radius cubed, and that gives us 179.6 when we round it. So the volume is 179.6 inches cubed. So prisms, pyramids, spheres. Keep those straight. Last one we'll talk about for this lesson is composites. Now, surface area with composites was miserable. So many things to think about. But when we're doing volume of composites, we just have to now, instead of all the faces, is just identify each solid shape. Calculate the volumes and add them up. So for this one, what makes up this entire shape? Well, the volume of this entire shape, well, there we go. We have a cylinder, which is a big BH cylinder, plus a second cylinder, so another big BH cylinder, plus a third big BH cylinder. But it's actually the same as these two, so I'm going to simplify my life and say that the volume is made up of two big BHs plus that other big BH. But the big B doesn't do anything for us other than make sure we know we're dealing with a certain shape. We have a circle, pi r squared, h. Pi r squared is our big B, plus it is a pi r squared as well in that one. Now remember, even though parts of these are connected in things, volume is the amount of space it takes up. We have all of this volume. Even though we don't have the ends of this middle one, we still have the entire volume of it. So it's 3 complete cylinders. So now we can substitute in 2 of these times pi. Now the radius of the big cylinders on the end, diameter is 12, so radius is 6 squared. And the height, distance from base to base, is 6.4. Plus the middle cylinder, which is the pi r squared circle times height. Diameter is 2.5, so radius is 1.25. So we have pi times 1.25 squared times the height, or the length between bases, which is 14.8. Big calculation, plug it in careful, but you get a rounded volume of 1,520.3 centimeters cubed. Try one more of those, but rather than do the entire calculations, here an artist, this is an add-on, so find a little piece of paper to do this. An artist created a sculpture, made it out of concrete. They want to know the volume of concrete that would be needed to create the sculpture. I don't need a final volume, but I want to create the entire equation that would be used to calculate the volume of the concrete. So I don't need a final numeric value, but I need to identify what makes up the volume here. Well, identify what you have. We have a triangular pyramid to start with. What else do we have making this up? We have this big rectangular prism box. So we have a rectangular prism. What else makes it up? Well, we have 3 cylinders. And let's assume that they're the same. That's what I wanted when I sketched it. They are. We have 3 identical cylinders. And what's a cylinder? A circular prism. Now this is where we can run into trouble if we don't think. We have a triangular pyramid. It's a pyramid. It's going to be a 1/3 big BH. We have the rectangular prism. It's a prism, just big BH. We have 3 cylinders. So I can find 1 cylinder and multiply it by the 3. A cylinder is a prism, big BH. Now I want to convert my big B's. Well, I have a 1/3. What kind of a base do we have on that triangular prism? Well, it's a triangular pyramid. It's a triangle base. So it's going to be 1/3, 5/10 BH, because it's a triangle, and then the height of the pyramid. Plus, we have the rectangular prism. So rectangle, base, and the height of it. And then we have 3 circular prisms. What kind of base do we have? Circles. Pi r squared times the height of it. So 3 circles times the height. There's the formula that could be used to calculate the volume of that sculpture. So, lots of information. But I put like 2 lessons in one because these all go together. We have one short lesson on volume next lesson, but here's your assignment. The booklet, page 45 to 47, those questions. Remember, I have my booklet included. You can get answers and see my steps. Check your work with the key booklet that was included. The textbook, answers at the back, but page 59, number 4 and 5, really good questions on composites. Important stuff. Not really complicated, but if you don't practice, you'll get things mixed up. Have fun.